Hello students, we were discussing conflict serializability. So today we will see how we can test for conflict serializability with ease. So we use precedence graph for this purpose. So this is like a precedence graph. So you can see that there is a transactions node represented by nodes, and there are edges between the transactions. So each node corresponds to a transaction, and the edge between two transactions TA and TB is created if one of the operation in TA if one of the operation in TA appears in the schedule before some conflicting operation in TB. So this is to remember the conflicting operation of TB. So in this way we will complete the graph, and then once the graph is completely drawn we check for loops. So if there is a cycle, we say that the schedule is not conflict serializable. So we will see one example. So there are three transactions, because you know that we represent the subscripts is as the transaction number, and bracket we represent the data item. So we have seen there are three subscripts 1 2 3, so T1, T2 and T3. Now there is, so you can see this W3A and this R1A. So it's both belong to different transactions, both working on the same data item, and the third condition is one of them is right. So we will draw age from 3 to 1. Fine. So this, there is a age from 3 to 1. So next we will see these two operations W3A and W2A. So there will be a age from 3 to 2. So this is a age from 3 to 2. So now W2B and R1B. So there will be a age from 2 to 1. So there is a age from 2 to 1. Fine. So fine, I think it's clear. So now 2 to 3, so there is one age from 2 to 3. So we have to see one age remains from 2 to 3. Okay, fine. So this is that combination, R2A and W3A. So both are on A. So there will be a age from 2 to A. 2 to 3, sorry. So this the complete precedence graph. So we can see there is a cycle. So these schedules are not conflict serializable. So we can say they are not free from they may not be free from RW, WR and WW problems. So we see the next schedule. So here also you can see there are three transactions. So I have drawn all the possible edges. So there is no cycle. So we say that this schedule is conflict serializable. So if we find that the schedule is not having a cycle, we call it a cyclic precedence graph. So in acyclic, if a graph is a cyclic graph, then we can find equivalent serial schedule. So there may be more than one possible serial schedule. We can find all those serial schedules by doing the topological sorting of the graph. So what is topological sorting? I think you have already read in DSA. So I am revising this. So we have to visit the vertices with the least in degree, and then we have to add that in the sequence, and then delete all the out edges of that vertex, and we have to repeat this until the graph becomes the zero vertex. So if I say for this example what will be the topological sequence, so the topological sequence we can start with T1. So one of the T possible, so this is so the lead T1 is having 0 in degree, so we will start with T1 for sure. Then there are two possibilities, T2 and T3. So here the in degree of T2 is 1 and the in degree of T3 is 2. So the second option is T2. So now we have removed this and this. So now the next option will be either T3 or T4, because both are having same number of incoming edges. So T3 T4, if T3 T4, then here it will come T4 T3, so this is T5. So in exams you will also get the question, what is the equivalent number of possible serial schedules? Fine. So this acyclic precedence graph is sufficient to say that the schedule is serializable, but it is not necessary. So what does this mean? So non-conflict serializable schedules may and may not be serializable. So this means the conflict serializability is very strict condition. So to so after this there is one more serializability, that is view serializability. So view serializability as seen in this diagram is a superset of conflict serializability. So once we check for conflict serializability, if it is yes, then we can surely say that this is serializable schedule. But even if this is not conflict serializable, we have to check for view serializability. So if it is a view serializable, then we say, then also we say that it is serializable. But if it is not view serializable, then we say that this is non-serializable. So now you are, I think it is clear to you. So there are two type of serializability, view and conflict. Checking conflict serializability is easy because it requires a simple cycle detection, drawing the graph and cycle detection, whose complexity is order of n square. So view serializability is more typical, and the I will explain you in next class. The complexity of that is order of 2 to the power n. So first we always check for conflict serializability, because if it is conflict then it must be view serializable. If not conflict, then we go for less strict, that is view serializability. So the conditions of view serializability I will explain you, but that is somewhat typical. So mostly we use cycle detection algorithm in the precedence graph for checking the serializability. So till this point everything is clear, I think. So you can find some more examples later on in my notes itself, so you can go for those. So next we will do view serializability. Thanks.